Example 4b is another one where we will have to complete the square to rewrite this in vertex form. The difference is our value of a is not equal to 1, so you can see we have a 2 there, which means when we set up our structure, so you can see right below that I do have the structure set up for completing the square. What we'll need to do is factor out this 2. So that will become f of x equals, factor out the 2, 2x squared divided by 2 will give us x squared, and then negative x divided by 2 will be minus 1/2 x. And then we will go through the process of completing the square. So we will add a value inside the parentheses there. We'll still have the plus 1 outside, and then to keep the equation balanced, we'll have to subtract the value out here. All right. So from that point forward, now we complete the square. And in order to do that, in that upper right-hand corner there, I have b over 2 squared. Our value of b in this case is that negative 1/2. All right, so we will do the value negative 1/2 divided by 2, and then we will square that. Okay. So when we complete that, you could also view that as the division by 2 there is the same as multiplying by 1/2. So you'd have like negative 1/2 times 1/2 squared. That will come out to be 1 over 16. All right. So we will add 1 over 16 inside the parentheses there. All right. However, when we work our way through to determine what we will add or subtract outside of the parentheses, remember we have to keep the function balanced here. So what we will need to do in this area here is subtract 2 times 1 over 16. All right, and that remains consistent with when we were solving by completing the square back in the previous units we looked at. So we'll put 2 times 1 over 16 outside there. All right, and now we can go ahead and continue on to get this into vertex form. So we'll have 2, and then we created a perfect square trinomial, so the square root of x squared will be x. We have minus 1/2 x, so the sign will be minus. And then we'll take the square root of 1 over 16, which would be 1/4. And then if we simplify everything that we have out here, all right, all of that info, 1 minus 2 times 1 over 16 is going to give us 7/8. So we will have plus 7 over 8. All right, so not the friendliest of values in this particular example. So that is our equation in vertex form. So we took care of that component of the problem. Now what we need to do is extract as much information as possible here. All right, so as far as the vertex is concerned, that should be pretty straightforward. It would be 1/4 and 7/8. We get that from here and here. This quadratic would open up. The quadratic opens up because our value of a is 2. All right, and if a is positive, the quadratic will open up, meaning it will have a minimum. The axis of symmetry, remember, that's always x equals whatever the x-coordinate of the vertex is. So we have a vertex of 1/4. You can see that's x equals 1/4. That will be the line that divides the parabola in half. The x-intercept, if we solve this algebraically, we could do that by taking this function right here and using the quadratic formula. If we found the discriminant for that, it would be negative. So this graph, and we'll see this when we actually go forth and graph it, there will be no x-intercept because it will not cross the x-axis. The quadratic will be above the x-axis, and it will open up. Therefore, it will never cross the x-axis. So there are no x-intercepts. It would have imaginary roots. All right. And then in order to find the y-intercept, the easiest way is to just use the equation that we have at the top here and plug in 0 in for x. So if we do that, we will get 0, 1 for our y-intercept. So if we look at a graph of this, not the easiest one to graph because of the unfriendly values of the vertex, but we have a vertex at 1/4 and 7/8, so that would be somewhere here. All right, 1/4 and 7/8 there. We know we have a y-intercept at 0, 1, okay, which I really can't plot all that well there. But if we wanted to find additional points on that graph, we've talked about how we can go to the right and left of the vertex. And again, this was on the first video, I believe, that you saw for this section. If we go 1 unit to the right and left, 1 squared is 1, and then we multiply that by our value of a, which is 2. So we could go to the right 1 unit and then up 2. So that would put us somewhere there. So to the right and then up 2 would be somewhere there. And then we can go to the left 1 and up 2, and it would mirror that. So it would be somewhere there. And then if we go to the right 2 units, 2 squared is 4, and then we can go up 8. So we'd have a point there and there. If we graphed our axis of symmetry, it would be the line that would divide that parabola in half. It won't be on the y-axis. My apologies for this. Not the best picture, obviously, to do this. But in the interest of time here, the axis of symmetry would go right down the middle there, and it would be that x equals 1/4. Okay. So moving on real quickly here. We'll finish off this one and then move on into a different video. In example 5, it says find 2 quadratic functions whose graph has x-intercepts at -4, 0, and 8, 0. So you can see I have a picture over here. And you know, a quadratic that has roots such as this can have an infinite amount of ways to be expressed. All right. In general, we could have a quadratic that passes through that looks like this. All right. That has roots at -4 and 8. The quadratic could open down and look something like that. We could stretch it out quite a bit. It could look something like this. All right. And that is all determined by our value of a. Okay. Now, if we put this into a format we should be familiar with, intercept form, all right, we would just plug those values of -4 and 8 in for r sub 1, r sub 2, okay, which are our roots. So we'd have y equals a times x minus a -4 times x minus 8, or y equals a times x plus 4 times x minus 8. All right. What we want to do is find at least 2. Let's find 2 quadratic functions that have those x-intercepts. So we can just pick out values of a, all right, to utilize. Before I do that, though, I will expand this. So x plus 4 times x minus 8 would give us x squared minus 4x minus 32. And then if we want to come up with 2 different quadratics, we just fill in a different value of a. All right, so maybe I want this quadratic to open up and I want a to be equal to 1. Well, if a is equal to 1 and I plug in 1 for this value, we'll just be left with what we have here. So that would be x squared minus 4x minus 32. All right. And maybe for another one, I want a to be negative. So I want the quadratic to open down. So if a was -5, we'll plug -5 into here. And then we'll make sure that we distribute that -5 all the way through. So if we do that, we would end up with y equals -5x squared plus 20x plus 160. You have flexibility here. You can choose whatever value of a you'd like. All right. But the bottom line is, for both this quadratic and this quadratic, they will cross the x-axis in the same location. All right.